beep. Last lesson before your test. So you will have this lesson today. Whatever the next day of school is will be a review day. The next day after that, you'll have a test or a quiz. I'm leaning towards test. Negative exponents and the laws of exponents. So here's what I want you to understand, especially because we're getting you ready for algebra. Never leave a simplified answer with a negative exponent. Okay? That is first and foremost, never leave a simplified answer with a negative exponent. So, one of the key terms that we need to know for our mathematical language, this would be a great piece to put on a separate piece of paper, is the word reciprocal. Okay? The reciprocal is the inverse of the term. So when I talk about the inverse, thank you. Okay.
Now that he's gone.
We think.
Okay. Okay.
Say hi to Miss Reeves, folks. Why are you sorry?
I didn't know you were recording.
Why are you sorry? Don't be sorry.
I didn't mean to walk into your recording.
No. Now you got to say hi.
Okay,
because here's what you guys have to understand. You'll see Mr. Reeves dressed up every single day. This is Mr. Reeves as a person. He is a person, folks. Just so you guys know.
I walked. I suspected it, but I don't know. I apologize.
So don't apologize. So the inverse of the term, what does that mean? Well, that means if I've got the number 3, 3 is a fraction, which is 3 divided by 1. The reciprocal, or its inverse, is 1/3. Okay? Well, what if I had x? If I had x, the reciprocal is 1 divided by x. Now, what we're doing today are negative exponents. So far we have not seen any negative exponents because we do not want a negative exponent in a simplified version of an answer. So if I've got x to the negative 7, we cannot have a negative exponent. So the first thing that we do is flip it. We make it a reciprocal. So immediately, this is 1 over x to the something. When we flip exponents, when we take the reciprocal of either a positive or a negative, it becomes the opposite sign of the exponent. So in this case, if it's x to the negative 7, it becomes 1 divided by x to the positive 7. That's important, okay? Because the better example is if I have 10 to the negative 2, and you plug that into your calculator, that would give you 0.01, okay? 100th. Well, why does that work? Because that's 1 over 10 squared, which is 1/100th. So 10 to the negative 2 is this decimal, but to show it as a correct simplified fraction, we have to show the reciprocal and change it to a positive. Okay? So, this is what it's saying right here. If I've got x to the negative 1, the reciprocal is 1 divided by x. If I've got x to the negative n, the reciprocal is 1 divided by x to the n. If I've got x to the negative b, it's 1 over x to the b. The only thing that's missing, because we don't have it, is what if we have 1 divided by x to the negative 8? Well, what has to happen? This goes from the denominator to the numerator. We don't need to flip the entire thing. The 1 can stay. Times, this comes up to the top, x to the 8. But remember, all of this still has to have a denominator. Now, why do I say it doesn't just flip? Because you might have something that looks like this. 3 divided by x to the negative 3rd. What exponent is with 3? Well, the exponent that's with 3 is a positive 1. there is no reason for me to do the reciprocal of 3 to the positive 1. So when I write this, 3 to the 1 stays. X to the negative third is in the denominator, so where does it need to go? It needs to flip, and it flips up to the top and becomes x to the positive 3 divided by 1. Well, do I need to write it like this? No. It's really 3. I don't need to put the exponent, x to the third. So this right here becomes this guy over here. So let's try a couple. Okay, so 3 times 10 to the negative 2. This is all in parentheses. So really what this means is 3 times 10 to the negative 2. Remember, this is all a fraction, so this is all divided by 1 right now. So to simplify this, I've got 3 divided by what happens to my base that has the negative exponent. It flips from the numerator to denominator in this case, because it's starting in the numerator. It becomes 3 to the 10 to the second. From there, could I simplify it? Sure, which is what it's asking me to do, because it's asking me actually for the value. So that becomes 3 divided by 100, or 3, to make it into a decimal, 3 hundredths. 3 times 10 to the negative 2, that's going to come in handy when we do scientific notation. But it gives me 3 hundredths. I would like you to do the same thing for exercise 3. And we'll talk about, do exercise 3, and exercise 5, and then we'll go from there. All right, so I lied, just do exercise 3. Let's just do exercise 3. Go ahead and pause me, do exercise 3. Okay, so one more time. We've got 3, and I'm just breaking it apart, times 10 to the negative 5th divided by 1. That leaves me with 3 in the numerator. 10 to the negative 5th needs to now flip, so it goes to the denominator and becomes positive. So that leaves me with 3. 10 to the 5th. How many zeros will 10 have if it's to the 5th power? Well, I would get my calculator. And it's going to have 5 zeros. So 1, 2, 3, 4, 5. So that's 3 100,000ths. So let's make sure tenths, hundreds, thousands, 10,000s, 100,000s. Oh my gosh, I love what I'm writing. So when I change this, that's 1, 2, 3, 4, 5, 3. Tenths, hundreds, thousands, 10,000s. So 100,000s. Let me make sure. Did I do that right? Yeah, I did. Woohoo! Okay, so has 5 zeros, perfect. Go from there. Last but not least, I would like you to do, so this one, we're just leaving in exponential form. I would like you to do exercise 5, 7, and 10. So I'd like you to do exercise 5, exercise 7, exercise 10. Go ahead and pause me, give them a try. Okay, so here, this becomes 1 over 5 to the third. This, I'm going to rewrite it first as this with 3 having an exponent. 3 has a positive power, so it stays. 2 to the negative 4th does not, so it needs to flip and become positive. Last but not least, same idea. This is really x times y to the negative fourth divided by 1. X has a positive power of 1, so it stays. Y to the fourth goes to the denominator and becomes positive. Okay. Almost done with this. And trust me, we will spend quite a bit on our review packet on these because I find negatives to be the trickiest, but that's just me. Okay, but what about these? So if I said that we're always subtracting, that's fine. I take the numerator minus the denominator. So now I have 19, 2 minus 5. And it's important that I write it that way. 2 minus 5 is 19 to the negative third. Remember what I said. You cannot have a negative exponent. You cannot have a negative exponent if you want something to be simplified. So now I divide it by 1, so that gives me 1 over 19 to the third. Mr. H, is there an easier way? Yes, I'd let you figure that out on your own. I'm going to let you try to figure that out on your own. So here we are in this one. What would I do here? Well, I have a couple different ways that I can do it. I can do 17, 16 minus. We're always taking the numerator divided by the denominator. Numerator, subtract. Oh, the denominator is a negative 3. Well, we learned last year that a minus and a negative give us a positive. So really that's 16 plus 3. That gives me 17 to the 9th. Mr. H, can you show me another way to do that? Yeah. So 17 to the 6th divided by 17 to the negative third. We cannot have this negative 3 in the denominator, so it becomes the reciprocal. It comes to the top. 17 to the 6th doesn't change. Why? Because it's already positive. Well, now it's 17 to the 6th times 17 to the third. We learned in lesson 1 that if we've got like bases, we add the exponents. Oh, 16, sorry. So when I add those exponents, I get 17 to the 19th power. Okay? So what I'd like you to do now is go ahead and get the exit ticket. Go ahead and get the exit ticket. You're going to be turning that in, and then you'll still have homework. So get the exit ticket, you'll be turning that in, and then you're going to do number 1 on the problem set. So exit ticket, turn that in, and then you've got number 1 on the problem set. Work together, good luck.